Small Frigidaire individual countertop one. It's pretty nice because it only works off 110 volts. I'm going to go ahead and press power, and I'm going to press high. Let's press set. I'm at the highest setting right now with this pan. Let's see what happens. What's it doing?
It's not sensing the pan.
It's not sensing the pan, right?
Because it's not a magnetic pan. It's not iron or steel.
So it's not sensing the pan. It's beeping, but it's not doing anything. I'm touching it, it's not getting hot. And because this pan doesn't have the steel bottom, it's not working. So if I can have this one, can you hear the difference now? So that's that high frequency. Now some of these have noise filters and stuff like that, but if there's no pan on there, it'll beep. Or in some higher end units might actually give a fault code. How does that know whether you have the right pot on it or not? I mean, we talked about not weight, because I was holding it sideways. I didn't even have the pan sitting down. If you look, this is a coil here, and it's just a coil of wire. So how does it know?
You feel it can sense the change in the magnetic field.
Yeah,
It closes the circuit.
Remember they said in the video it acts like a transformer. So this is our primary winding of transformer. This is where we put power in. Okay, now we gotta have power coming back out. If you use this pan here, this one is made out of aluminum or copper. It doesn't create what they call like a drag on the electrical current. It's trying to, it'd be like water just flowing with nothing slowing it down. So when you hook this up, the magnetic field in this pan actually creates a drag on the current flow. And because of that drag, it knows that you have the proper pot in there. Okay? Yes?
So almost like resistance with an ohm meter.
Well, it does create a resistance where this one had little or no resistance to the flow going through the burner. So I'm going to go ahead and we'll do just like they did in the video. I'm going to take a piece of paper here.
Put some water on it.
And we're going to put some water in our pan here.
Put a magnet in the one.
I'm going to put too much because the more water I put, the longer it'll take. Turn it on, set power. Let's go to high. And it's still pulling the drag. If I lift it up a little bit, it's too far away. You lose your drag. Now it's not like a real strong magnetic field distance-wise. It's the frequency. Okay? So in a few seconds it starts to create a few bubbles. I can feel already the water's already warm. Alright, now I'll let you guys try it out after the lecture. And then if you want to like stand up, you can see what it's doing in a second. You'll start seeing bubbles are starting to form in the bottom of the pan. They're starting to cook. Now, the one thing about these is they're just computer boards. There's not a lot you can do on the board itself. If the coil is good and resistance-wise if the coil is good, it's not shorted or open, then the only thing left you have is a board to replace the board. Yes, sir?
Does it cycle on and off like traditional?
If you go into lower powers, it doesn't cycle on and off, it changes the frequency. So instead of 1,000, 20,000 pulses like the video, maybe it's 15,000 pulses. Yes?
Is that why it's humming like that? You can hear the frequency behind that?
Well, the frequency of the electricity changes, it's making that noise. Part of the noise also is a lot of these have a fan inside. Because of the heat being generated, the heat we have generated, we need to cool down all the electronics that are down underneath it. Right now you can start to see steam coming off the pot. If you were to put this on a regular burner like on here, this wouldn't even get close to boiling that fast. If you see, we already got steam coming off of it. So the water temperature is getting hot real fast. Okay? And the heat throughout the bottom of the pot is even. You can move it a little bit here and there, and it doesn't affect it. If you put it on the coil burner, and you move it a little bit left or right, it actually affects. Part of it's not cooking, the other part is. So we got almost a full raging boil coming through here. Inside of this particular unit, we have 2 burners. This little wire here is is actually the thermistor. This is what's sensing the temperature. Basically, it's only a safety device. If it gets too hot, we don't want the glass to break. And then we got this coil here, and then you got a board underneath it. So we got two separate burners, so the board underneath is broken down into two identical circuitry. One for this burner, one for that one. But there is a difference in it because of the size of the coil and the amount of heat we're put. Now if you look at this video here, we're at a full raging boil. I take it off, the boiling's almost completely stopped. It's still steaming, but it's no longer boiling. I put it back down, and in seconds, it's gonna start boiling to full boil again. And already it's starting to boil. Okay? So, in this frying pan, we take this paper, it's got a little bit of water on it, but the paper is just warm. Like it came out of a copy machine.
Is it the surface it's hot?
It's a little bit warm in the middle because the water was boiling, so it's close to 200 degrees. But if I got this pan right here, I'm boiling water right now, and my hand's sitting on this frying pan. I'm touching the pan.
This is the dark sword.
Well, I'm not touching the pan. If I touch the pan, I get burnt.
Can you
But
see
it
that?
is safer. To you, here is boiling water in my hand. Look, it's on the pan. Right, look, I'm just barely touching that pan. You guys want to come up here and give this a try?
Hey, dog. Put the mic in.
Well, let me see. Where's that magnet at?
Yeah,
Right there next to your other induction top.
sorry. Freaking out.
You're gonna break it.
Boy.
Go ahead. It doesn't detect it.
Oh.
Change
Flip
it.
Flip it upside down.
Put it.
The polarity change?
It's alternating current,
Oh. That's the point.
so it's not working, is it? It was beeping. It didn't detect it.
If it's alternating current,
Because
is-
the surface,
Guys, that's his mic.
I thought it had the rectifier in it.
Well, remember,
Or is that in
it
the
was
course?
when the power came in, it was 120 volts, 60 hertz AC. It went through rectifiers that converted it to 120 volts DC. Still 60 hertz. The cycle's still 60 hertz. But the rectifier lets half of that through. Okay? Now they put it to an inverter. The inverter raises the voltage and puts it back to alternating current. Now it went from 60 hertz to 20,000 hertz. It's the frequency. Microwaves cook at a frequency of 2,450 megahertz. This is cooking at 20,000 hertz. So frequencies are different, right?
Yeah.
So 2,000 megahertz. Microwave's frequency is a lot higher than the frequency of this. And the difference is that we're trying to magnetize this pan. That's all we're doing. Okay? But in a microwave, the magnetron is cooking from a distance of about 10 to 12 inches away from the food. So we have to induce that electrical current through the air and force it into the food. So the frequency is a lot higher, a lot stronger. And with that higher frequency, believe it or not, it does not travel a longer distance. Okay? If you stood far enough away from a microwave, it would not affect you. But if you were in front of a microwave, like within inches, you could feel the heat being generated off of it. All right, so I'm not getting in today to troubleshooting. Let's go ahead and take a look at the questions you guys had to answer on the assignment. Describe in your own words how induction cooking works. I don't really want to go into that, but basically we take electricity, we increase the frequency, and it induces magnetism in the pan, which creates heat. You know, you're gonna have to put that in your own words. If you want me to read your definitions, I'll make comments or something like that, but I'm not gonna go over everybody's individual interpretation. Might be slightly different. But if you say, is this right, I'll read it for you if it's right. It says page 4, let's see here, page 4. It says here, the first test you should make, I didn't type that right, when checking the induction cooktop for errors is what? power.
Oh, okay.
That's pretty much any appliance, okay? Even the induction cooktop. You could not have the proper voltage. You may have 80 volts, 90 volts. Is that gonna allow the unit to cook like it's supposed to? No. It's not going to get to that 20,000 kilohertz frequency, okay? So, one of the things you wanna do is, most common mistakes by technicians fail to verify the incoming power. The only times I've seen people, especially in these competitions, dryer runs no heat, they tear the whole machine apart. Never check the power in the wall. And that actually happened to some Sears technician years ago. I'm not gonna get into details there. But it's actually happened and I watched them do it.
Z
How-
also said sitting in under load, right?
What?
When you're verifying the power of the machine, while it's sitting in, also,
Yes, under load would be as if you had the right power, you might wanna check. And why would you do it under load?
if you have the power drop, I guess, when turn it on.
An example of that would be like the wires are connected into the outlet in the wall. Most wire is stranded, like it's like 30 or 40 strands of copper wire and then a screw screws down. Sometimes they don't catch all the screws, so you only get like 2 or 3 strands and the rest are not in there. So if you check voltage, it'll read 200 volts. But like a water hose, the water hose may be this big and when water's coming out of it, it's gonna shoot that thickness. But if you have a water hose this big, and then you're coming out of an opening that's this big, you know, you're not gonna get the full amount of water flowing out, so as soon as the appliance comes on, the voltage drops. And it could be burnt, could be just poor connections. So yeah, you wanna check it under load, but you wanna make sure that the wiring, the circuit breaker, and everything else is in good condition as well. How are accidental turn-ons from happening? You guys know what page that was?
Page 13, that was the other one.
I didn't write down the page of the answer.
Right there.
Right there. Yeah, there.
Okay. Pan size detector. The recognition sensor automatically detects and adapts the cooling zone pan size used. So the unique feature is whether turned on or off, the cooktop surface remains cooler, but the coil sensor automatically detects whether the pan is magnetic and eliminates accidental cool downs. So we even put a magnet down there and it still said, hey, there's no pan there. Because the magnet was not slowing down the way the current was coming out of that coil. The coil was just freely producing electricity. But once we put this pan on there, it created a drag on that current. And the board monitors the actual flow and the drag. So it's got a magnetic detector. The magnetic detector is not part of the coil itself, it's part of the circuitry underneath monitoring the power going to the coil. Okay? So if you had it where it says, oh, it's not detecting the pan, and I know it's a brand new pan, it's not necessarily the coil, it's usually the board underneath. Okay? What's the next question? Okay, those were the pans, and we went over the answer of what pans will work and what won't. Number 5, what does it mean when the below letters appear in the cooktop window? So we had some fault codes in this, and I forgot what page that was. That's installation. I'll upload this book too, just in case you guys need it. Display images. Yeah. Okay, here were the 3 that we said. We got HLF. H means residual heat. Once any cooking zone has been used for cooking and turned off, if the top of the surface is cooking, it's too hot, H will appear. So almost like when you're using a glass top stove. When you're done, it's got a little on indicator light and it's also got a hot surface light. This hot surface light will stay on till the top of the stove cools down. Well, if I was cooking on here, you notice how we had a piece of paper there that didn't burn, but it was still a little hot. If I cook for like 30 minutes at that kind of temperature and take the pan off, the glass will be hot to the touch. Not too far away from the burner, but right in the middle. You don't want to be cooking on it, then walk away and someone comes home with groceries or someone puts, something on top of it and that glass is hot. So it has an H there just to warn you, hey, this is hot. Now that H isn't universal to all brands. This is only this particular brand from this book here, okay? L, keep warm. Use the warm or low keypad to activate the warm setting for any cooking zones. So basically, if you're cooking, but you're not ready to serve, and you still have something in the oven or something like that, you can put it on low heat, and it'll just keep the pan warm so that the food stays hot when it's ready for serving. Okay, so that's the L. F is pan detection. All 5 cooking zones provide a pan detection method. If it does not detect that the pan is on there, on this particular model, it'll give you an F saying, hey, you either don't have a pan on the right burner or you have the wrong type of pan. Alright? So that was those questions. Error 32 or 72. What did you guys put down for that?
Low voltage.
Output from 12-volt supply on filter board.
12 volt supply and filter board?
No voltage output.
Let's get to the fault code page here.
Filter. 25 supply.
Okay, so it was 32 or 72.
Yeah.
Low voltage output from the 12 volt supply on the filter board in the 3 cook zone induction module. 3 cook zone means that it has 3 burners. Okay, again, remember this is to this one specific model that has, I think, 5 burners on it. And one board controls 3 burners, the other board controls 2 burners. So if you had low voltage, test all your cables, replace the circuit board, and you're only gonna see this kind of stuff on the more high-end units. So what I mean by high-end is like, you know, the big 30 or 36 inch or even the 42 inch cooktops. You're gonna see more fault codes on them. Like this Wolf here or this little Frigidaire cooktop that we have that's induction, they're not gonna give you all those fault codes. They're just a little bit smaller and compact. This one doesn't really have fault codes. This one, when the pan wasn't on there, all it did was what? Beep. Okay, so you just have to identify with each manufacturer what that is. You're really not gonna find too much technical information on this small 1 burner thing. It was like 60, 70 bucks, you could buy it. The biggest thing we found with these Frigidaire cooktops is a little fan motor inside of there that keeps it cool would stop running. And when it stopped running, guess what? It would not cook. It would not work at all. We had to rig up some fans that we got. I think Dudley here fixed them for me. And we rigged up some fans that ran off of the same voltage, and they worked. This particular unit is so inexpensive, they do not sell replacement parts for it. So when it breaks, you throw it away.
Yeah.
You could not buy parts for it. Like a Yugo? Like a Yugo. Okay, what about error 45? Incoming power supply voltage. So that means, like you were saying, is that the power coming into the unit might be too low. If we have low voltage, board may or may not work, probably will not. The main power board would see that the voltage is too low, and it's gonna automatically flash an error code on it. Alright? There's a bunch of error codes on here, and I could have put a bunch more numbers on there. I just wanted you to be familiar with what the codes are and how to read this chart and everything. And error code 74.
Internal generator.
Internal generator error communication. What am I talking about there?
The board is not communicating.
Okay, well, we have 2 main boards on these. One is the filter and power supply board. That's where the power comes in, and it goes through that. What does the filter do? We talked about filters on like the front load washers and stuff like that. And microwaves have little filter boards on them.
Reduce the
It's what?
Noise filter,
What is noise filter?
frequency filter
For what?
for
You're saying the words right, but you're not saying what it's doing.
Yeah.
Anybody else know?
frequency.
Yes.
Reduce the frequency.
Yeah, but that's on the power supply coming in. Why do we have this noise filter on the power supply coming in?
It keeps the voltage from fluctuating.
No, because it's gonna fluctuate through the generator board, but not through the filter board. What happens is, no, it's actually preventing backfeed from the appliance feeding back into the house electrical. Okay, remember we saw the video, it said 60 hertz and it went to 20,000 hertz. Well, what if that frequency of 20,000 hertz fed back through the line into the rest of the house. It's not gonna destroy the other appliances, but it's like the old vacuum cleaners when mom was vacuum cleaning, you're watching TV before they had cable and you had like an antenna, and lines appeared across your TV screen, or you're listening to radio and you get those noises. It's the motor is generating a feedback of frequency through the power supply different from the incoming frequency, and it makes a noise. One thing it's hard for people to fathom is you could have a wire, and on the Electrolux refrigerators, there is a wire coming from the main power board to the inverter board controlling the compressor. And you can check AC voltage, DC voltage, and the frequency on the same two wires. That means you can have AC voltage, DC voltage, and you can measure a frequency on just the two wires. So how could you have AC and DC voltage on the same wire? Well, they're
Different
running at
frequency.
different frequencies. And you're saying, what? Well, your cable TV, y'all know what a coaxial cable is. It's that thick round wire, and it has a single wire in the middle and a bunch of looped wires around the outside. Those two wires create your signal. But you have 150, 200 channels of TV coming through that one strand of wire. Not only do you have TV, but it's video and audio. Video and audio are actually running on different frequencies, and each channel is being transmitted at one frequency, and the cable box in your house is just filtering out that one channel's frequency, so your TV only shows one channel. But they got hundreds of different frequencies running through that single line, and they send it out one way, and they got a filter on the other end that picks it up and filters out all the other channels, so your TV only displays one channel. We call that a tuner. You know, back in the old days, you turned the dial and you had channel 7, channel 4, whatever. The frequency was generated through the air. Channel 4 and 7 were on different frequencies, and your tuner was only tuned to receive the signal from that one channel, channel 7 or channel 4. That's the frequency. Now they just got more technological when they put that cable TV and put 150 channels on that same wire. Okay? So here we have the internal generator area. The internal generator is the main board that's generating the electricity to the coil of wire. And they're saying here that there's a communication error in that board. The board itself is faulty. There's something wrong with that generator board. That's what they're trying to tell you. Check the cables, check to replace the circuit, and check the generator board. So somewhere in there, there's a problem with the circuitry, and 9 out of 10 times on these high-end induction units, you're going to change the boards, but you got to be able to identify what boards failed. That's all it is. You're a parts replacer, but you got to understand how it works. So when something goes wrong with it, there's not a lot of tests you can make on this board to see if it's working properly or not. Could you check the frequency to this coil? Yeah. You can find those 2 screws on that board and put your meter on a frequency scale and actually watch the frequency coming out. The problem is, you don't know when you're on high, medium, or low what the actual frequency reading's supposed to be. So you can ohm out this burner coil, and if the burner coil checks good, what's wrong?
The board.
The board. Those boards are so expensive nowadays. $350, $400, $600, $800, $1,000 boards.
Yeah, but aren't most of those high-end machines gonna cost you $2,000 or $3,000 anyways?
If you can afford to drive a Porsche or Mercedes, you can afford to fix it when it breaks.
Which means they can afford to pay me to fix it.
Oh, there was a customer that came into our warehouse with 2 boards for his induction, induction stove. The problem is that he said he changed up the two boards and it still gave him the same problem. The thing was that he said that each board cost him about $900 for some crazy deal about how like.
Probably a GE.
Yeah, it was.
That shit's like a lot of
Those GE boards are super expensive.
Yeah.
Anybody got any questions on this assignment?
Idiot.
No, I'm not gonna collect it, but, towards the end of the trimester, you're gonna have a test on this, the LG refrigerator that we talked about, the compressor on that, the linear compressor. Some of these other lectures that we've had, unfortunately, we didn't record the refrigerator lecture. So, Mike, can you turn that?